Do you see how everything fits together? All right, next question. Last thing in this lecture was, hey, can you differentiate between equal and equivalent vectors? Ugh. Are equal and equivalent the same thing? Nope. Tell me what equal means. What's the sign of equal vectors or equal forces? Go ahead. Same magnitude, same direction. So I got a force 100 up, I got a force 100 up on this side. Are they equal? Yes. Are they equivalent? Well, what does equivalent mean? They have the same what? Effect on the body. Usually the effect, at least in this class, is they generate the same moment. So I got a force here, here's the center where I'm taking the moment at. This force is creating a 100 times this distance. Let's say it's a circle, so it has a radius. There's the center. It's creating a moment that is counterclockwise. This is the force that's acting here. The force that's acting on this side from the center is creating what? A clockwise. Are they equivalent? No, because they're not producing the same effect. One effect is producing a counterclockwise, the other effect is producing a clockwise. That's not the same effect. And in the video, I give you 3 examples. Please review those. Where equal vectors are equivalent, equal vectors are not equivalent, equivalent vectors are not equal. I think those are the 3 cases. Okay? Please review them. It's up to you. That's a synopsis. I am not going to take this long to do a synopsis anymore. I'm going to come in, give you a 5 to 8 minute synopsis of the video, and I'm going to proceed to do problems. This was way longer than I expected to do. Why? Because the majority of you did not watch the videos. You got to start coming to class, having viewed the videos. If you don't, none of this will make any sense. Okay? So those people that watch the video goes, yep, I remember that. Yep, I checked that out. Yep, he said that in the video. Yep. You, the rest of you are looking and going, I don't understand what the fuck he's talking about. Let's do the first problem. Somebody got a ruler for me? I need to borrow a ruler, please. Anybody got a ruler? Oops. Got it. All right, first problem. Let's talk capiche here. First problem. It says, this is so, doesn't it look kind of, if I can focus this up a little bit better. Yeah. Is that better? I've got this tower that's attached to that tower, 2 cables. And this is, you can see this all around. When you see cell phone towers, you'll see a bunch of cables coming off. And there's usually a bazillion of them coming off to keep the thing kind of stabilized. I just took that and said, there's only 2, just to make life simple. One cable has 10 kips. Okay, so what the hell is a kip? What's a kip? 1,000 pounds. Do not ask me on the test, hey, what's a kip? My answer is going to be, I don't know. So 1 kip equals 1,000 pounds. Somebody got their testing manual with them? Testing manual? A red book? Who's got it? Come on, bring it up. Let's go. Gracias. So, oh boy. notice what question number 2 says. 1 kip is 100 pounds, true or false? So if you didn't come to lecture, you would know the answer to that, would you? Because that's the first time I saw it. I said it. Interesting. Let me, let's see. Oh, look at this one. Finite rigid body rotations are vectors, true or false? Did I not say that today? Today in class I said, hey, finite rotations have magnitude direction, but do not add according to the parallelogram rule, therefore they are not vectors. Poof! There it is. It appeared on the damn quiz. Now, if you're not here, how the fuck are you going to know that answer? A force can be considered a sliding vector. This is where I told you, please read the first 8 pages of the Procopy booklet. Because in the first 8 pages of the Procopy booklet, it describes free vector, a bound vector or fixed, and a sliding vector. It actually describes all 3. Well, if you don't read the first 8 pages like I told you to do today, you won't know the answer to that, would you? Okay? Got it? Alright, so the first thing I'm going to tell, it says, find me the direction and magnitude of the resultant force. Great. The first thing I'm going to do is I'm going to draw what's known as a free body diagram. If you read the first 8 pages of the Procopy booklet, it describes what a free body diagram is. It's the whole body. It's a portion of the body. It's whatever you want it to be, as long as you account for all the forces. It is the engineer's accounting ledger. That's how we keep track of forces on things. If you go to fluids or thermal, they don't use free body diagrams. They use kind of an equivalent, there's that word, equivalent thing, which is a control volume. Same shit. They're trying to account for what's coming into that volume, what is being worked on in the volume, and what's coming out of the volume. Okay? Same idea. Control volume, free body diagram. You're going to hear this over and over and over. Now what I'm going to do is I'm going to isolate this, and I'm going to circle this point C. And over here I'm going to say this is C. And notice my circle cut that line and cut that line there. So I'm going to show a vector here, 10 kips. And I'm going to show a vector here this way, 15 kips. I'm going to put a coordinate system. Well, the only freaking coordinate system we use in this class is x, y. Here's my y. Here's my x. Like so. Please, somebody tell me what that angle is right there. Huh? What's that angle there? 45 degrees. My man says 45. How many agree? How many disagree? How many don't give a shit? How many thinking, oh shit, I should have had lunch before coming here? Or better yet, damn, I ate lunch, I feel like I need a nap. How many are thinking I need a nap? Do you really? Come on, man. Maybe you should go to sleep earlier.
Yes.
What time did you go to sleep last night?
5 in the morning. What do you have class? Midnight?
What the hell were you doing all that evening?
I just couldn't sleep.
You couldn't sleep.
I haven't slept yet. I just couldn't sleep.
So what'd you do?
I just laid on my bed trying to sleep.
You did what?
I laid on my bed trying to sleep.
And flipped and flopped.
Yes.
If the exam I can get it, but really? Wow.
Sorry. Pocket, wonder you need a fucking nap. Okay. What angle is that 45? Tell me why. You know I ain't gonna ask you the why. Why is that true? Alternate interior angles. Oh, remember that from geometry? How many did not take geometry in high school? Did not. Okay, so Don't come with me, I don't know how you got that angle. You should know. Notice, if I draw a line here and a line here, those are two parallel lines, there's the transversal. Alternate interior angles say, alternate interior angles must be congruent. So that's 45, that's the alternate interior 45. That's 60, this has to be 60. Yes? Who's not with me? So I know this is 45, that's got to be 60. See, senor? Yes? Yes. Now, here comes the parallelogram rule. I'm going to take this, and I'm going to slide it down here like this, and I'm going to draw a line. That's going to be AC. I'm going to take this sucker, and I'm going to draw a line, like so, parallel to the original, and it's going to look like that. And I'm going to make it slightly longer because 15 is greater than 10. And then, Mr. Wonderful here is going to connect the tail of the first to the head of the second. That's going to be my result. So, by the way, doesn't matter whether I say A plus B or B plus A. No, why? Because it's geometry, right? Next, once I have the triangle, I need some angles. Well, if that's 45, then that is 45, because of alternate interior angles. That's 60, so from the horizontal down to here, that's got to be 60. Well, if that's the case, what's this whole angle now? 105. This is 10, this is 15. What do I have here? Do I have a right triangle? Do I have a right triangle?
No.
No. If I did have a right triangle, then instantly I'd go to Sukato. I don't have a right triangle. What do I do? Can I cry? What do I do? Go ahead, 2.4. Come on. Law of cosine. How many remember the law of cosine? Oh, shit. You want me to remember the law? Yes, I do. Let's review it. Law of cosine says, if you have two sides and the angle in between, which is called the included angle, my r squared is equal to 10 squared plus 15 squared minus 2 times 10 times 15 times the angle in between, which is 105. This is the law of cosine. You can see it in the appendix in the ProCopy booklet if you want to see it generic. If I solve this, I'm going to get r roughly 20 kips. Case 24, comma 066, whatever. I just route it. I don't really care at this stage. That's great. Except I need what from you? What do I need? Huh? No, it's kips. What do I need? I need the direction. Because it's a vector. I need both magnitude and direction. I already know that it obeyed the parallelogram rule. I added head to tail. The head of 10 to the tail of 15. Parallelogram rule has been satisfied. There's my magnitude. I need a direction. What's my direction? Here comes the law of sines. Crap. This is going to say, let's call this angle theta, this angle theta. I'm going to write law of sines now. Sine says sine of theta over 10 is equal to sine of 105 over 20, which is the result. Sine of beta over 15. What's the law of sine say? Hey, sine of the angle and the side opposite. The side opposite is the 10. Sine of beta and the side opposite would be the 15. And sine of 105 and the side opposite would be the R. Yes? Now, if I solve these two together, I'll get theta. If I solve these two together, I will get theta. If you solve, you'll get theta equals 28.78. Beta is equal to 46.22. There's my angle. However, you go to the back of the book and you look for the answer. You ain't getting the answer of 46.22 and 28.78. It's not going to be there. Oh, did I do something wrong? No. Because usually the answer is given relative to a horizontal or a vertical. Neither of these angles is relative to a horizontal or vertical. This is not exactly horizontal. So that beta is not with respect to horizontal or vertical. This angle of theta is not with respect to horizontal or vertical. If I want to do it relative to a horizontal, I need that angle. I'm going to call that phi. How do I get phi? It's 180 because the line is 180 degrees minus 45 plus beta 46.22. Phi therefore is equal to 88.78 degrees. So my answer is, and this would be my answer, resultant is 20 kips, and the direction is given as 88.78, in essence in the fourth quadrant. If I look at this as quadrant 1, quadrant 2, quadrant 3, this is quadrant 4. Now, that's not the only way I can do it. I can say, or it is relative to the vertical 1.22. Remember, relative to the horizontal is 88.78. If I sum the two, I should get 90. So that's my solution. That is my solution to the problem. I'm giving you magnitude, I'm giving you direction, and when I construct the triangle, I created a head to tail which obeyed the parallelogram rule. Any questions? Now, please note, next week's quiz. Notice what it says. Using the parallelogram rule of triangle construction, find me the resultant of these two forces. No credit given for component method. It's going to read identical to that. The only difference is you're going to get a different diagram. That's it. You're going to get a different diagram. Got it? Please pass these back to me. Next problem. Turn the page. Here we go. So the boat is moored in the river by two ropes, BC and AB. It is known that the resultant force is a magnitude of 203, so the resultant is 203, directed upstream. So what did I just give you? I just gave you the result. What do you think this problem is? It's a resolution. The next statement says, hey, take that 203, find it along BC and along AB. Notice what it says? Oh, can't see it. Yeah. Tell me the magnitudes of forces of the ropes AB and BC. So this is telling me this is a resolution problem, not a result. Free body diagram. Look, I'm going to draw it right here. So free body diagram says I've got here point B. I got a force this way, which is TBC. I got a force this way, which is TBA. And I have a resultant this way, which I know is 203. That is my result. Yes? So there's the free body diagram. Now I'm going to do triangle construction again. I'm going to take this sucker, and I'm gonna move it here. That's TBA. All I did is I took my ruler, slid it down, I'm still parallel to the TBA. I'm gonna take this sucker right here. I'm gonna draw it here. Can I borrow a pencil? Just real quick. Process. I'm gonna draw this line right here in pencil for right now. That is the line of action of BC. Agreed? So I gotta draw a vector along here someplace. Plus, I gotta draw a horizontal line, like so. That automatically tells me, hey, head to tail, that puts here T, BC. I know this is 203. I know this is 45. Why? Because it's 45, TBA 45 relative to horizontal. There's TBA, that's a horizontal, that's 45. Here, horizontal to DBC is 28. I know that's going to be 28. This angle is theta. What is theta? Well, what's the sum of the angles of a triangle equal to? 180. So theta has to be 180 minus 45 plus 28. Theta has to be equal to 107. So now what do I have? I have all the angles of the triangle and one side. What's that lead me to? That's the law of sines. True or false? If I'm doing a resolution, I will be using the law of cosines. If I'm doing if I'm doing a resultant, I'm going to use the law of cosines. If I'm doing a resolution, I'm going to use the law of sines. True or false? The answer is true. So anytime I do a resolution problem, the first thing I'm going to do is do a law of sines. So here we go. Here's the law of sines. I'm going to say sine 45 over TBC is equal to sine 107 over 203, which is equal to sine 28 over TBA. Again, it's the angle and the side opposite. It's the angle and the side opposite. It's the angle and the side opposite is what you do as the ratios. This should lead me to 2 TBC, which is equal to 179 TBC is equal to 150.1, TBA equal to 99.66. Pounds. Okay? Now, so resolution, always think law of sines. Resultant, always think law of cosines, and then you have to use the law of sines to get the angle. By the way, don't be shocked. Don't be shocked if you look at the back of the book and it says 88.78. It doesn't say 88.78, but gives you this angle instead, which would be the obtuse angle. So it'll give you some obtuse, 348. Because Hibbler likes to go from the positive x-axis all the way to the vector. I don't want that. I want the acute angle, so I want this angle. I do not want the obtuse angle from the positive x all the way to the vector. Got it? All right, let's go back to this one. So we did part A. Part B. Tell me the magnitudes of AB and BC. If the force AB is to be a minimum, oh crap, minimum? What's the first thing you think of when you hear the word minimum? If you're an engineer, this is what you should be thinking. What do you think when you see the word minimum? Huh? What's the first thing in your thought process that comes in? I know what I think of right away. I see the word minimum, I think this instant. What do you think when when you see minimum? What? Derivative. Remember back in Calc 1? They gave you a function and said, hey, find max min. What'd you do? You took the derivative. You set it equal to 0. Got what? Critical points. What were those? Possible max and min. Then what'd you do? Then you said, well, what they taught you was, hey, do the first derivative test. You find the critical point, go to the right, go to the left. Test its concavity. Right? Then they said, oh, there's an easier way to do this. You see how calc people do this? When you started doing derivative, what's the first thing they did? Limits. Then they said, oh, by the way, there's an easier way. There's the product rule, the quotient rule, blah, blah, blah. You didn't do any more limits. Same thing here. Right? You with me? Who's not with me? So, second derivative test said what? Hey, if the second derivative at the critical point is less than 0, what did I get? Oh shit, you want me to remember calc? Yes, I do. Unfortunately for you. What did I get? What is it? Max or min? Max. It was greater than 0. Got it. Well, I'm not going to do derivatives. Can I? Yes. And I will do a problem down the road that does that. Here, I'm going to do it graphically. So I'm going to take the 203, boom, here it is, 203. I'm going to take this guy, the tension BC. Can I borrow a pencil again? Thanks. I'm going to take BC and I'm going to draw its line of action. Here is its line of action. There's the LA. Yes? That's going to be where I put BC. Now, I got to take this BA and connect it. Well, there's lots of ways to connect it. Watch. Any of those vectors can connect head to tail between BA and BC. Which one's the minimum? Which one looks like the smallest? The perpendicular, which is this guy right here. Yes? So this is my TBA to create a minimum. This would be my This is my BC to create a minimum. And now what do I have? I have a right triangle. What's the first thing you do when you have a right triangle? What's the first thought process you have? What? SOHCAHTOA. When I don't have a right triangle, what's the first thought you think of? Law of cosines, law of sines. From this point forward, that's what you should be thinking. Okay? So now all I have to do is say, so that's 90. This angle is still 28. So this angle here, sorry, it's kind of goofy, is phi. Phi is going to be 180 minus 90 plus 28, which is 62. I can then say sine of 28 is just opposite over the hypotenuse. That's TBA over 203. TBA is 95.3 pounds. And I can say cosine of 28 is equal to TBC over 203. TBC is equal to 179.29 pounds. Yes? Who's not here? Who's not with me? That's the graphical way to find the min. Down the road when we do compounds, I'll show you the derivative way to do min. Got it? Remember, tomorrow, first quiz is mostly math. Yes, you'll have some true-false stuff, but it's basically on what we discussed